review of factoring, the types of factoring that we've talked about so far. So if you look at the first one, give you a quick little refresher. Think about, is there a GCF? First question off your mind here. You need to kind of do a check mark. Is there a GCF? Do they have something in common? So kind of think about that question and then try and factor those problems. So Will, does the first one have a GCF? Yeah, what do they both have in common? A 4. So we'll pull that 4 out. And then Will, when you pull out a 4, divide by 4, what do you have? So we have an x squared and a 1. Can that be factored any further? Abby?
4x minus 1, x plus 1.
Very nice. It actually can be factored further because 1 is a perfect square. It's the first perfect square. It's the one that nobody thinks about. 1 times 1 makes 1. That means it's still a perfect square. 2 times 2 is 4. 3 times 3 is 9. But 1 is a perfect square, and negative 1 times positive 1 is how we can get that value. So this would factor as 4, pulling out the GCF, and then x minus 1, x plus 1. So it does factor another step after you take out that 4. The next one for letter B, we have negative 3y squared minus 18y. Eden, what can we pull out of there? Do they have a GCF in common? Negative 3y. So both of them have a negative 3, but they also contain a y because we have a y squared and a y. And Eden, what's left inside them? Yeah. So if you're dividing by negative 3y, that's what you're really doing when you're pulling out a GCF. So there's negative 3 divided by 3, that's gone. But you have a y squared, you're getting rid of one of them, so there's still a y left over. And then negative 18 divided by negative 3 is positive 6. Those y's are gone because you took it out. So it's sitting outside. Letter C, we have negative 4m squared minus 10m plus 24. Is there a GCF? First question. Julian, is there a GCF for letter C?
2.
Yeah, they have a 2 in common. What else could you probably pull out with that 2? Since the first thing is negative.
Negative 2.
Yeah, so generally when the first term is negative, you pull that negative out. We try and keep an expression to be positive. So besides a 2, we can pull out a negative 2. So they do have something in common. Do they all have m's, Julian? No. So only pulling out a negative 2 gives us what?
So you have negative 2, 2m,
You're good.
and then 5m,
Good.
and then negative 12.
Nice. There we go. So pulling out the GCF, the negative 2, we have 2m squared plus 5m minus 12. And right now, that's all we can do with that problem. Today we're going to talk about how to factor a problem like this when there's a number in front. We haven't factored so far with any number in front. It just is an x squared sitting there. So we're going to stop right now with that one, but we will be able to solve that in a little bit. The last one here, 5z squared minus 25z plus 40. Maggie, what do they have in common? A 5. If you take out a 5, what's left?
Z squared minus 5z plus 8.
Okay. And then, Maggie, are there any 2 factors of 8 that will give you a negative 5? So think of the factors of 8. What multiplies to be 8? 3, 2, and 4? 2 and 4 multiply to be 8. What else multiplies to be 8? 8 and 1. Will any of those combine to make a negative 5? No. So this is as far as we can go factoring this, because the combinations that multiply to be 8 will never add to be a negative 5 for us. So they were all GCF problems. The first one was like a two-step because we could take out a GCF and then factor with the perfect square. But GCF is that first question that we need to ask ourselves. Do they have something in common? Questions. So today we are going to be factoring with a term in front. So not only factoring with the x squared, but there's going to be a number in front of that x squared. And as you see up at the top here, I guess underneath the word the AC method, we have this 5x squared. We actually call this AC grouping. So we're going to be using a type of factoring called grouping. But we're also going to be using the AC part. So we call it AC grouping. And this is pretty much like the traditional common way to factor problems that have a number in front of x squared. So any number sitting in front of x squared needs to be factored in a special way. And this is the way we're going to try and factor it. And there's a couple of steps here. So the first step says multiply a times c, which is why it gets its name, the AC method. A is the first number, c is the last number. So now because there's a value sitting in front, that value affects the factors. All the other problems that we've done so far just had a 1 in front. That's why we didn't really worry about that number. 1 times anything is still the number itself. So we're going to multiply a times c. In this case, a times c is a positive 30. The second step says find the factors of the product AC, which in this case is 30, that add up to b. So remember, b is the middle number. So the process is similar. We're going to think of two numbers that multiply to be 30, but add to be negative 17. So thinking of the factors of 30, all right, there's our factors of 30. I kind of just went in order. We want those factors to combine to be negative 17, but also multiply to be positive 30. Odette, do any of these factors combine to be negative 17? Right, negative 15 and negative 2 make negative 17 when you combine them together. They also multiply to be positive 30, and you need to make sure both numbers are happy. So we got to multiply to be the top number, but combine to be that middle number. All right, here's where it kind of now is different from the way that we've done it. So we've taken a times c, we've listed the factors that try and combine to be b. The next step says to factor by grouping. We're going to set this equation up, or the expression up, a little differently. So we're going to keep the 5x squared, but we're going to change the middle term, the negative 17, using the two factors that we said made negative 17. So we have, I'm going to write the 15 first, negative 15x and negative 2x. So this is now different from the other factoring that we've done. The other factoring, we jump right into parentheses, and we're no longer jumping into parentheses. So we're going to take the two numbers that add to be negative 17, and we're going to write them in the middle. It still makes negative 17, because negative 15x minus negative 2x is still negative 17x. These guys still make negative 17. We're just writing it slightly differently. And then there's a plus 6. So we kept the first term, we kept the last term. We're just changing the middle. Does anybody know what to do next? And it depends who you had last year, if you did this extensively or you just did it a little bit. You do, yeah, you break it into two pieces, two parts. And we're going to just put a little line down the middle. So we're going to split this into two parts. There's 4 up here, so we're going to split the first 2 versus the second 2. Maddie, do you remember what you're looking for with the first 2? Yeah. Yeah. Right, you're looking now for a GCF. So we're going to use GCF to help us factor. So we have a 5x squared and a 15x. We're going to take the GCF. They both have a 5 in common and an x in common. So now we're using the GCF of this pair. We've grouped them together because they have something in common. That's what this little line does. It groups the front together, it groups the back together. Maddie, if you take the GCF out, what's left in the parentheses just for those 2 sets of numbers? How about just x minus 3? There you go. Alright, so we're gonna do the exact same thing with the back part. So we're looking at negative 2x plus 6. What's the GCF of negative 2x plus 6? So what do they have in common? Gavin? Say it again. So they have a negative 2 in common. If this term is negative, we pull the negative out with it. And then Gavin, what do they have then in parentheses when you take out a negative 2? X minus 3. So you're taking out that negative 2 because they have it in common. Alright, so if you look at this, it's still a messy looking expression. It's not yet factored. What do you notice by looking at what we have up here? Melanie, what do you notice?
We have the same like stuff in parentheses.
Yeah, we have the same stuff in the parentheses, that same expression. That happens every time by factoring with grouping, if you've grouped them correctly, if you pulled out the correct GCF. So factor by grouping says that if you're pulling a GCF out, that parentheses part that's been factored should be the same. So there's one last step that we're going to do, and now we're going to literally pull our factors together because our answer should be a set of parentheses, 2 sets of parentheses. So we're going to take the 5x and the minus 2. Because they're both being multiplied by the same quantity, we can pull them together as a pair in a set of parentheses. So we can say 5x minus 2, both of them were being multiplied by x minus 3. I don't write x minus 3 twice because separately they were being multiplied by x minus 3. Together now, they're still being multiplied by x minus 3. So we don't write that quantity twice. We can do that because they had the same set of parentheses. If that was different, then we could not pull them together. So now this is factored. It looks like our answers from last week, where there's 2 sets of parentheses, but the method is different because there's now a 5 sitting in front. Before we just said x minus 2, x minus 3. But now with that 5 in front, that kind of changes the problem a little bit. Questions? So it says to check with FOIL just to kind of make sure that you're seeing that it truly does work. This method does work to kind of give us a factoring problem. So foiling this out, this is just my check step. You don't have to check it. And make sure though that you did correctly factor it. We have 5x squared minus 15x minus 2x, and then my last term plus 6. And this is exactly what we started with. Questions? A little different. The process is the same every time. So we have a couple examples on the next page. We're just going to work through this method. So it's a little more involved when there's a number in front. You can't just pick 2 numbers and place them right in parentheses. So we have 2x squared plus 9x plus 7. Anytime there's a number in front, that's when you need to use this method. So the first question, is there a GCF? Do 2, 9, and 7 have anything in common? That's always the first question to ask yourself. No, they don't have anything in common. They're 2, 9, and 7. So nothing in common there. So that means then the next step, we're going to take A times C. So 2 times 7 is 14. We need the 2 numbers that multiply to be 14, but add to be 9. So 1 and 14, 2 and 7. Bram, how would those combine to be 9?
7 and 2.
Yeah, 7 and 2. So 7 plus 2 combines to be a positive 9. All right, here's where the next step changes a little bit. This one's different. So we're taking 2x squared, and then we're taking the 2 factors. So a plus 2 and a plus 7. And we're placing them with x because our term had an x. It's supposed to make 9x, so we're making 9x by using 2x and 7x. And then the last one was a 7. So right here is my 9x, which was still in that original problem. We just kind of wrote it differently. So now that I have this expanded, this is called expanded form. We're going to place a little line down the middle. That's like our barrier wall. And we're gonna factor out what the first pair have in common in front of the line and what the back pair have in common. So Connor, what do the first pair have in common in front of the line here?
2x.
A 2x, and when you take a 2x out, you get,
X plus 1.
yeah. So we have an x, and then 2x divided by 2x is a plus 1. You have to have something there, so 2 divided by 2 is 1. Don't leave it blank. And then Connor, how about the second pair of numbers? What do they have in common?
7.
A 7, and it's a positive 7. Make sure you're writing a plus sign here. So this is currently an addition problem. So we've got a plus 7, and Connor in parentheses, when you divide by 7,
X plus 1.
we end up with x plus 1. So this factoring works because the parentheses are the same. If they're not the same, then you pulled out the wrong GCF. So because they're the same, we can take the 2x and the 7, pull them together, because they're both being multiplied by x plus 1. So separately, they're multiplied by x plus 1, but they're like terms. So together, they're being multiplied by x plus 1. Questions? I want to go down to the next two because there's negative signs in these. That one didn't. Those other ones didn't have any negative signs. So if you look underneath, again, it says use this AC, we call it AC grouping method to factor. First question, is there a GCF? So we have a 3, really a -1, and a -2, so no GCF. We're going to start the process again, taking A times C. So this time it's a -6. Make sure you're writing that negative with the number, because it's important that we're multiplying to be a negative number, not a positive number. So Mackenzie Mallory, what numbers multiply to be -6? Or just start with 6. What numbers multiply to be 6?
-3 and 2.
So -3 and 2, we would also have a 1 and 6. But a -3 plus 2 make -1. That's what we're trying to combine to be. -3 plus 2 is -1. So rewriting it, 3x squared minus 3x plus 2x minus 2. And if you're looking at those factors, like if you see that we have like the first number is a 3x squared, so I would sit the 3 with that 3x squared because then they have something in common. They both are divisible by 3. When you're writing your two factors down, kind of look at your first number and your last number, and you can order your factors based off of what they have in common. So Mackenzie, what would we take out then?
3x from the first two.
So 3x here, and that gives us,
X minus 1.
and then
2 and the second.
positive 2, and that also gives us,
X minus 1.
nice job. So your answer is,
3x plus 2 and x minus 1.
nice job, good. Questions? Alright, so let's do another one. Let's do one more here. I want to make sure everybody feels pretty confident about this type of factoring. So, is there a GCF? Abby, do 4, 8, and 5 have anything in common? No. Okay, so then multiply 4 times -5. So Abby, what multiplies to be -20 but adds to be -8?
-10 and 2.
So she said -10 and +2. If you need to write the factors down because you don't see it initially, that's fine. So write those factors down until you see a pair. Sometimes it helps visually seeing things written down to come up with a set of numbers that work. So because I have a 4 in the front, I'm actually going to place the 2 with it. And then the 10 I'm placing second because there's a 5 in the back. The reason I'm doing that is because 10 and 5 are both divisible by the same value. So I kind of took my factors and paired them together based off of what they had in common. So Abby, if I have it set up like this, what would 4x squared and 2x have in common?
2x.
And if we take a 2x out,
2x plus 1.
yeah, we have 2x plus 1. And then the second pair have
-5.
a -5. It's negative, so that means what we take out is negative. And then in parentheses there, Abby, would be
2x plus 1.
nice. And then the last thing is to just pull those pieces together. So Abby, your final answer looks like
2x minus 5 times 2x plus 1.
very nice. Questions? So I'm gonna stop there. So I'm gonna give you the little quiz. It's not on this stuff. It's from last week. So difference of perfect squares, is there a GCF? Just traditional, like the basic factoring. But your homework tonight is multiples of 3. So you're not doing 3 to 48 even. You're not doing 3 to 48 odd. You're doing the multiples of 3. So 3, 6, 9, 12, 15, 18, 21, 24. So that's a little different, but you're going to look at those multiples of 3. And this is just 4 questions. You don't have to do this, I don't think there's the credit. Or you can try it and I can see how you do. I don't have to grade you. Just make sure you place your name on the top. Again, this should be factored, so your answer should be in parentheses, not x equals 5 and x equals 10. This is set in parentheses.